So I want to briefly review the translation and transformation formula. So this is our formula, g of x equals plus or minus the function plus or minus 1 over b times x minus h plus k. So our a, or our negative, is the reflection over the x-axis. Our a determines our vertical stretch and shrink. Our b, or our negative, in front of the 1 over b, reflects over the y-axis. X minus h will shift right h units. Negative h shifts left h units. Now note what happens. Because the formula is x minus h, x minus negative h gives us the x plus h, which we know shifts to the left. So that is how it actually works, is x minus h, the h is positive, it shifts to the right, x minus negative h shifts to the left, but in the equation you'll see it as x plus h. So let's talk about horizontal dilation. The actual factor is 1 over b. b is the horizontal dilation by b units. So in the example, I have g of x equals f, 3 times x plus 4. Well, 3 equals 1 over 1/3. So therefore b equals 1/3, which means that our function will shrink or compress by 1/3. And also look at the x plus 4. X plus 4 equals x minus negative 4, which means it will shift left 4 units. So hopefully that will clarify some of the parameters in our formula and make your solving of equations easier. So for lesson 1.4, we're going to go into more detail on transformations of absolute value and quadratics. As you may recall, a quadratic function is a function where the highest exponent in the function is x squared. The parent function, or the parent equation, is f of x equals x squared. The domain is all real numbers, and of course we can write that in our interval notation. The range, or the y values, are from the vertex all the way to infinity. And that's assuming it's not reflected. Again, we're talking about the parent value. If it is reflected, then the y values will go to negative infinity. And again, that is if it is reflected. So notice, here is an example of the parent function where it's not reflected. If we reflected it, it would look something like this, where it would be upside down, and you can see that the y values would be negative. So again, the range of the parent function is going to be from 0, which is the vertex, all the way to positive infinity. Now let's go on to absolute value. So absolute value, a little bit similar to the quadratic equations. The range, or the y value, is going to be from 0 inclusive to positive infinity. Again, this is the parent function. And if it is reflected, it's going to go to negative infinity. If it's reflected, it's going to go from 0 to negative infinity. And again, here's an example of the parent function. And if we were to reflect it, it would look something like this. As you can see, if it's reflected, the y value is going to negative infinity. Let's go ahead and discuss something called mapping rules. So mapping rules are created when both the x and y are used to transform the original equation. Let's go ahead and do an example of a mapping rule and use our parent functions. So if I wanted to use just -2, -1, 0, 1, 2, my f of x and my x would be as such. So I have -2, -1, 0, 1, and 2. And notice f of x is the absolute value of x, so my y, or my f of x, is going to be 2, 1, 0, 1, and 2. And again, here is how the absolute value looks when I plug in or show all my parameters. Now, for our quadratic equation, we'll also do the mapping rules. And again, I have x, f of x, which is also y. And notice I have my -2, -1, 0, 1, 2. So when I plug in my f of x, it's going to be 4, 1, 0, 1, and 4. And again, here is my quadratic as it's plugged into all of my parameters. So what we're going to do next is work some examples. And what we're going to do is take a parent function and then use the transformation or the image function and discuss and put into a table how we're going from the parent into the image, or how we're going from f of x to g of x. We're then going to go ahead and make a rule of our point xy, which will be basically a formula for x and a formula for y that will allow us to use a table of numbers and get the transformed x and y. So let's go ahead and work an example. In this case, we have the parent function is the absolute value of x. F of x equals the absolute value of x. Our image function is our g of x, which is below. So let's first go ahead and look at our transformation. So our a parameter is this parameter here. So our a parameter equals 2 with a vertical stretch by 2. Our b parameter is in this parameter here, and our b equals 4, and that's a horizontal stretch by 4. Our h parameter, which is the parameter that determines our left and right displacement, our h equals -1, which means it's a left shift of 1 unit. And then our k parameter is a -3, and that means that we have a downward shift by 3. So we also have a reflection. So notice we have a negative in front of here, which means we have a reflection, which is going to be over the x-axis. We're going to go ahead and set up our formula for our x and y. We have a horizontal stretch by 4. So that's going to be 4x. And then we go left 1, so that's going to be -1. For our y, notice we have a vertical stretch by 2, and we have a reflection over the x-axis. So it's going to be -2y, and then it's going to go down by 3, so it's -3. So now we have our formula for our x and y's that we can then plug in with a table for absolute value for this transformation. So notice we have vertical compression, which is at 1/2. So that's going to be a vertical compression by 1/2. I have horizontal. So notice my horizontal is 3, which means that my b value is actually 1/3, which is going to be a horizontal shrink, or you can say it's also a horizontal compression by 1/3. Now we also have a shift, and our shift is going to be 2, and that's going to be a right shift of 2. And then we also have a vertical shift, and notice that that's plus 3, and that's just going to be a vertical shift upward of 3. So now let's go ahead and go over our transformation x's and y's. So for our x, we'll do 1/3 x, and then notice it's going to go plus 2. And for our y, it's going to be 1/2 y plus 3. So there you have our formula for our x and y values for this equation. And we can do a similar thing with this equation as well. And what we can do is go through this. So our a value equals 2, which is a vertical stretch by 2. Our b value is going to be also 2, which is going to be a horizontal stretch by 2. Our h value is a -2. So it's going to be a left shift by 2. And then our k value is -3, which is a downward shift by 3. Our x and y formulas, for our x, we have a -2x, left shift -2. For a y, we have a stretch by 2, and then we're going down 3. So now let's go ahead and do the same thing for our quadratic equations and see how that looks. So notice for our a parameter, we're at 1/3, which is a vertical compression by 1/3. Our b parameter equals 1/3, and that's going to be a horizontal compression by 1/3. Our h parameter is +4, which is going to be a right shift of 4. And our k parameter is +2, which is an upward shift of 2. So let's go ahead and do our xy conversions. For our x conversion, it's going to be 1/3 x plus 4. And then for our y, it's going to be 1/3 y plus 2. And now we can use that to transform our new graph. So let's go ahead and look at this problem here. Again, very similar. First thing we have is I have a negative, which is a reflection over x. And notice I also have a reflection over y as well. My a parameter is a vertical compression. Notice my b parameter is actually 1, so there is no horizontal compression at all. However, I am going to move my graph right by 5, and I'm going to put it down by 4. So my x value is going to be simply -x plus 5. My y value is going to be -1/2 y minus 4. And for our last one, again, my a value is 1/4, which is a vertical compression. My b value is 2, and it's a horizontal stretch by 2. My h value is a negative 2, which means I'm going left 2. And my k value is minus 3, which takes me down 3. My xy, my x value is negative 2x minus 2. My y value is 1/4 y minus 3. And that's our transformation formulas. So now we're going to try some examples using the techniques that we just finished learning. So the first thing we're going to do is look at these equations. And notice we have different transformations. The first two, a and b, are absolute value. C and D are quadratics. So first thing that I did is in purple, I wrote the parent function. I also graphed the parent function on all these graphs so that you could see the difference after the transformation. Also, our table of values, notice we have negative 2, negative 1, 0, 1, 2, and the corresponding y of the parent function there as well. So let's go ahead and first see what we're doing with problem A. So let's go ahead and do h. So we see that h is going to be plus 2, and k is also plus 2. And don't forget, our formula is f of x minus h plus k. So our minus 2 is positive. So let's go ahead and graph these. So first thing we're going to do is make a formula with our points. So let's go ahead, and our transformation x will be x plus 2. Our transformation y is going to be y plus 2, and that's based on these here. And now we plug into our table. So we have negative 2 plus 2 is going to be 0. We have negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is going to be 3. And then we have 2 plus 2 is 4. Let's do our y. Y plus 2. So 2 plus 2 is 4. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. So let's go ahead and graph these. So we have 0, 4. We have 1, 3. We have 2, 2. We have 1, 3. And then we have 4, 4. So notice that these points, they are red, of course, across. And that's our transformation. So now let's go ahead and try this problem over here. So let's start off. Notice we have a negative, which means we're going to reflect over the x-axis. So we have b equals 2, h equals negative 3, and k equals negative 2. So now let's go ahead and do our transformation x's and y's. So now let's do our transformation coordinates. So for our x, we have a stretch of 2, which is our b. So it's going to be 2x. And then we're going to go left 3, minus 3. Our y, we simply are going down 2, so it's y minus 2. And we're going to reflect over the x-axis. So the first thing I'm going to do is do our reflection over the x-axis. So this is our parent function reflected over the x-axis. Now you'll see, as we plot our points, you'll see it that our reflection is going to work here. So with our reflection over the x-axis, we're going to make this y actually negative to reflect that. No pun intended. And now we'll go ahead and plug it in. So we have negative 2 times 2 minus 3, which is negative 4 minus 3, which is going to be negative 7. I have negative 1 minus 3. Negative 1 times 2 minus 3, rather, is negative 5. 0, 2 times 0 minus 3 is negative 3. 2 times 1 is 2, minus 3 is negative 1. And 2 times 2 is 4 minus 3 is positive 1. Now we go to the y's, and we have negative 2 minus 2 is negative 4. We have 1, negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. Negative 1 minus 2 is negative 3. And negative 2 minus 2 is negative 4. So now let's go ahead and graph it. So we have negative 7, and I'm going to make an extra negative 7 out here on our graph. So we have negative 7, negative 4, and then we have negative 5, negative 3, followed by negative 3, negative 2, then negative 1, negative 3, and last but not least 2, negative 4, and now we draw our line. So notice that our absolute value function is both flipped, it's reflected, and it has shifted left 3 and down 2 compared to the parent function. Our next two problems are quadratics. So notice our parent function is f of x equals x squared, which I've graphed here in purple, and the table also reflects our parent function in purple, f of x equal x squared, that we'll use during our transformation. So let's go ahead and fill in our parameters. So we have a equals 2, which is going to be a vertical stretch. And then we have h equals 4, which is going to be a right shift of 4. And we have k equals negative 3, which is going to be a downward shift of 3. So let's go ahead and do our x and y transformation formulas. So our x is going to be x plus 4, and our y transformation is going to be 2y, which is our stretch, minus 3. So now let's go ahead and make our coordinates on our table of values. So we'll first do our x's. So negative 2 plus 4 is 2, negative 1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5, and 2 plus 4 is 6. Now we'll do our y's. 2 times 4 is 8 minus 3 is 5. 2 times 1 is 2 minus 3 is negative 1. 0 minus 3 is negative 3. 2 times 1 minus 3 is negative 1. And 2 times 4 minus 3 is going to be 5. So let's go ahead and graph our points. So again, we read across 2, 5 is our first point. So we'll go ahead and do 2 and 5, followed by 3, -1. And then we have 4, -3, followed by 5, -1, and then 6, 5. We draw our graph, and you can notice that the graph is shifted, and you can see the shape difference where it has actually been stretched vertically. Our next problem, it's very similar, and let's go ahead and do this. It's a little different. So now we have a horizontal dilation. So we have B equals 2, which is going to be a stretch, a horizontal stretch of 2, and then we have our H equals -1, and our K equals -1. So our H of -1 means a left shift of 1, and our K of -1 means a down shift of 1. So let's go ahead and make our XY transformation formulas. So first thing we're going to do is do 2x minus 1 followed by our y, which is going to be y minus 1. Now we plug in our values, and I get 2 times -2 is -4 minus 1 is -5. 2 times -1 is -2 minus 1 is -3. 0 times 2 is 0 minus 1 is -1. 2 times 1 is 2 minus 1 is 1. And 2 times 2 is 4 minus 1 is 3. Let's do the same thing for y. And we have 4 minus 1 is 3. 1 minus 1 is 0. 0 minus 1 is -1. 1 minus 1 is 0. And 4 minus 1 is 3. So let's go ahead and graph. So let's go ahead and first do the x's. So -2 times 2 minus 1 is -5. -1 times 2 is -2 minus 1 is -3. 2 times 0 is 0 minus 1 is -1. 2 times 1 minus 1 is 1. And 2 times 2 minus 1 is 3. On the y side, 4 minus 1 is 3. 1 minus 1 is 0. 0 minus 1 is -1. 1 minus 1 is 0. And 4 minus 1 is 3. So let's go ahead and graph these. So we have -5, 3. I have -3, 0. I have -1, -1. I have 1, 0. And then I have 3, 3. I draw my line. And you can see that my new transformed parabola is stretched compared to the parent function. And that's it. If you have any questions, please let me know on Monday.